Good day, viewers. My name is Dr. Chris Isekhaigbe. I will be bringing you the part 3 of how to calculate quartiles, deciles, and percentiles. The part 1 talked about the calculation of quartiles, deciles, and percentiles for ungrouped data. The part 2 also talked about quartiles, deciles, and percentiles for ungrouped data. We looked at the various equivalents and we were able to prove them using a set of ungrouped data. Today I will be bringing you part 3, and this part 3 we shall be looking at how to calculate quartiles, deciles, and percentiles for grouped data. Grouped data are data with class intervals and frequencies. I'm sure you are used to this set of data. We have been using this since we began. This is the set of data we got when we created a frequency distribution table from a set of 30 observations. We got this in one of our videos, and we shall be using this data set today, this ungrouped data, to see how we can calculate quartiles, deciles, and percentiles. Now, there are two key things that are needed anytime you want to calculate percentiles, quartiles, and deciles, because percentiles, quartiles, and deciles are measures of position. They are also called measures of location. For the quartiles, we have the general quartile formula as Qi is equal to L plus I summation F all over 4, because the quartile divides the data set into 4 equal parts minus the cumulative frequency before that class all over the frequency of that quartile class times our class weight or class size. Then for the deciles, we have a general formula as this: Di is equal to L plus I summation F all over 10 minus cumulative frequency before that class all over the frequency of the decile class times the class weight C. Then our percentiles are calculated using this formula: Pi is equal to L plus I summation F all over 100 minus the cumulative frequency before that class all over the frequency of the ith percentile class times our class size or class weight, which is C. Now, if you look at these are measures of position. Now, the first thing you do in statistics, you write out the formula of what you want to calculate successfully. Then you now come and begin to create everything that is necessary on the table. Now, these earlier are the lower class boundaries, so we need to create the class boundaries. We are not using this one directly. The essence of creating the class boundary is to expand more. You will reduce the lower class of each class by 0.5 and add it to the upper class. This for this class is 6 minus 0.5 is 5.5. Then 10 plus 0.5 is 10.5. 11 minus 0.5 is 10.5. 15 plus 10.5, 15 plus 0.5 is 15.5. 16 minus 0.5 is 15.5. 20 plus 0.5 is 20.5. 21 minus 0.5 is 20.5. 25 plus 0.5 is 25.5. 26 minus 0.5 is 25.5. 30 plus 0.5 is 30.5. 31 minus 0.5 is 30.5. 35 plus 0.5 is 35.5. 36 minus 0.5 is 35.5. 40 plus 0.5 is 40.5. Then again, you will look at this particular part of the formula. We have the cumulative frequency before. So this means that we need the cumulative frequency column. And how do we get the cumulative frequency column? You get that from the frequencies. You put the first frequency here, 3. You add it to the second frequency. 3 plus 5 will give you 8. You add 8 to the next frequency. 8 plus 9, 17. You add 17 to the next one. 17 plus 5 is 22. You add 22 to the next one. 22 plus 4 is 26. You add 26 to the next one. 26 plus 1 is 27. You add 27 to the next one. Then 27 plus 3 is 30. Now, there must be a balance. You see the sum of the frequency is 30. And when you have done the cumulative frequency, you will arrive at 30. If they are not equal, it means something is definitely wrong with your calculation. It means something is definitely wrong with your calculation. So these are the formula that we use to calculate the quartiles, the deciles, and the percentiles. The quartiles, we have 3. The quartile is sharing the data set into 4 equal parts. That's why we are dividing here by 4. The decile is dividing the data set into 10 equal parts. That's why we are dividing by 10. Then the percentiles is dividing the data set into 100 equal parts. That is why we are having it divided by 100. So it will interest you to know that now we are going to see how we can calculate our quartiles first. We are going to be looking at, we have the 3 quartiles, the first quartile, the second quartile, and the third quartile. So we'll start by first of all calculating the first quartile. Our first quartile will now be I will be 1, Q1 is equal to L plus 1 times summation F is summation F all over 4 minus the cumulative frequency before that class all over frequency of the first quartile class Q1 then times C. So you have to have this. This is now the formula for calculating the first quartile. Now there is what I call the class determinant. Whatever measure of position you want to calculate, the first thing you need to do is to determine the class where that particular measure of position falls, where it falls. So now this value, this particular value here is what we call the class determinant for quartiles. This summation I summation F over 4. For the Q1, we have to determine the class where the Q1 falls. And it's now we are now using this one. It's now summation F over 4 is equal to 30 over 4. 30 over 4 will now be equal to 7.5. Now, if you look at this, where does 7.5 falls within the cumulative frequency column? You will see that here is from 0 to 3. Then once it is more than 3 to 8 is this class. So 7.5 falls here. So this class is our Q1 class. So everything we need for our Q1 will be here. So it means that from here, our L will be equal to 10.5. Then our cumulative frequency before that class will be equal to, before the class is 3. And the frequency of that Q1 class, the frequency will now be 5. So FQ1 will be equal to 5. So these are the things. Of course, we know our class weight is 5 from the data set here. Our class weight is 5. From 6 to 10 is 5. 6, 7, 8, 9, and 10. 11 to 15 is 5. So all inclusive. Now let us go ahead and calculate our Q1. Our Q1 will now be equal to L is 10.5 plus summation F over 4 is 7.5 minus our cumulative frequency before that class is 3 all over our frequency of that is 5, then times the class width C, which is 5. So this will now leave us to having 10.5 plus 7.5 minus 3 is 4.5. 4.5 all over 5 times 5. This 5 here, we cancel this 5. So our Q1 will be equal to 10.5 plus 4.5, and that is equal to 15. So our Q1 is 15. Our first quartile is 15. So go ahead again and calculate the second quartile. I hope this is understood. Please subscribe to my YouTube channel. Click on the bell button by the side of the subscription so that you'll be able to get a notification anytime I upload a video to my channel. God bless you as you do that. Share my video to your various social media platforms, your WhatsApp status, your Facebook, and the rest of them. Like the videos, click on the like button and share them. As you do that, God blesses you. So this is how we can calculate the first quartile for the grouped data. Now let us go ahead and calculate the second quartile. Let us go ahead and calculate the second quartile. These things are very cheap and they are very easy. Now, for the second quartile, you are going to have it as, from this, is the second quartile is known as Q2, and this will be equal to L plus I here is 2. I here will be, this will be 2 summation F all over 4. Then minus the cumulative frequency before that class all over the frequency of the Q2 class, then times C. Now you need to determine the class before you calculate the quartile, the second quartile. Now the Q2 class is gotten from this determinant here. I told you this thing that is circled is the class determinant. That is what we use to determine the class, where each measure of position falls. So here, this one is 2 summation F over 4 is equal to 2 times 30. Remember our summation F is 30, the sum of the frequency all over 4, and this will be 60 over 4. 60 divided by 4, that will give you 15. Now you will now come, where does 15 fall? 15 has left this class. You will go again to the cumulative frequency column. If you look at this here, 15 is more than 8, so therefore it falls in this class. Now you write out everything you need. The L for this class, that is the lower bound for the class, is L will be equal to 15.5. Then our cumulative frequency before it, the one above the class will be 8. And the frequency of that Q2 class, will be equal to 9. Look at the frequency column is equal to 9. Now this will now lead us to calculating the second quartile. From here, our Q2 will now be equal to L is 15.5 plus 2 summation F over 4. We have already calculated that one to be 15, plus 15 minus the cumulative frequency before that is 8, minus 8 all over the frequency of the Q2 class is 9, then times 5. So this will be equal to 15.5 plus 15 minus 8 is 7 all over 9 times 5, and this will be equal to 15.5 plus 7 times 6 is 35 all over 9. And if you divide 35 by 9, you will get 3.89. So our Q2 will be equal to 15.5 plus 35 divided by 9 is 3.89. You add this together, our Q2 will now be 19.39. 19.39 for this set of data. You can see that. So now look at the class where the Q2 falls. The Q2 class is 15.5 to 20.5, and this particular value 19.39 falls within this class. It falls within this class. So you can see it. 19.39 falls within the Q2 class. The Q2 class is 15.5 to 20.5. So the value calculated must fall within that class. There is one thing, knowing the class and knowing the value. The value must fall within that class. If the value, for instance, if the value we calculated is 19.39, if it is above 20.5, then our answer is wrong. There is something wrong somewhere. And if it is below this 15.5, then something is also wrong somewhere. Now permit me to go ahead and calculate our Q3, which is the third quartile. So I'll clean everything about the second quartile so that we'll go ahead. I hope you are taking note of these measures of location, measures of position, the quartiles, the deciles, the percentiles for grouped data. Now we want to calculate our Q3. Our Q3 is equal to L plus, now you see I is now 3. It's QI. This will now be 3 summation F all over 4 minus the cumulative frequency before that class all over the frequency of the Q3 class, then times C. The first thing is to use this class determinant. So for the class determinant to determine the class where the Q3 falls. So this will be 3 summation F all over 4, because quartiles is the third quartile, that's why it's 3. If the second quartile, it will be 2, I will be 2. Here our I is 3. So this is, in instance, 3 times, again our summation F is 30 times 30 all over 4. That is equal to 90 over 4. 90 over 4 will now be equal to 22.5. Is equal to 22.5. 22.5. Now, let us bring out the things that we need. Where does 22.5 falls? Look at the cumulative frequency column. Now, this place is 17. This place is 22. But what we have there is 22.5. It simply means that it has left this class by 0.5. So the Q3 class is this class. So it's now this class where 26 falls. So that means our lower value, or let me write it, our Q3 class is equal to 25.5 to 30.5. Here our L is equal to the lower class 25.5. Then our cumulative frequency before it, it is the one above it, that is 22. Then our frequency of the Q3 class, the frequency of that class is 4. So our frequency is now 4. So you can see that we have all that we need to calculate our Q3. So now let's go ahead and calculate it. Our Q3 will be equal to the lower class, which is 25.5 plus 3 summation f has been calculated to be 22.5 minus the one cumulative frequency before it is 22 all over the frequency of that class is 4, and of course our class width is 5. So this will now be equal to 25.5 plus 22.5 minus 22 is 0.5 all over 4 times 5. Now if you go ahead and do that, you will now have our Q3 is equal to 25.5 plus 0.5 times 5 is 2.5. It will now be 2.5 over 4, and this will be equal to 25.5 plus 2.5 over 4 is 0.63. 0.63. Please note we are working with 2 decimal places, so it's 0.63. So if you add this to that, our Q3 will now be equal to, the final answer for our Q3 will now be 26.13. 26.13. That is our final answer for our Q3. So our Q3 will now be 26.13. Again, you will check there are opportunity, or there's an opportunity for you to check if your answer is right or wrong, or is on track. Your answer, the value for the Q3 must fall within the Q3 class. The Q3 class is 25.5 to 30.5, and this 26.13 falls within this class. That means we are on track. 26.13 falls within the Q3 class, which is 25.5 to 30.5. Now let us look at the interquartile range and the semi-interquartile range. Interquartile range and semi-interquartile range. Interquartile range and the semi-interquartile range. Now, I told you the interquartile range helps us to detect suspected outliers in our previous videos. So the interquartile range IQR is given as IQR is equal to Q3 minus Q1, and that is equal to our Q3 is 26.13. This will be 26.13 minus our Q1 is 15. So our interquartile range is equal to 26.13 minus 15, and that is 11.13. Then our semi-interquartile range SIQR is equal to Q3 minus Q1 all over 2, and that will be 11.13 all over 2. Then our semi-interquartile range will now be equal to 11.3 divided by 11.13 divided by 2, and that is 5.57. So it's 5.57. So it's good you know how to calculate this. The interquartile range IQR is 11.13, and the semi-interquartile range, you now divide the interquartile range by 2, and that gives you 5.57. This is all about quartiles. Now it is good we go ahead and see how we can calculate deciles. Then from there we move to percentiles, and so on and so forth. Now we shall be looking at deciles. Remember, by definition, deciles divide the data set into 10 equal parts. 10 equal parts. You are sharing the data set into 10 equal parts. 10 equal parts. That is what the deciles do. Now, I will give the formula again. Di is equal to L plus I summation F all over 10 minus cumulative frequency before that class all over the frequency of the decile class times our class size, C, class size or class weight, whichever way name you want to call it. Now, I will first of all start by calculating my D3, the third decile. So our third decile will be D3 is equal to I is now 3. So this will be L plus 3 summation F all over 10 minus the cumulative frequency before that class all over the frequency of the third decile class times our class weights or class size, C. Like I told us, the first thing we need to do here is to know the D3 class. We have the class, what I call the class determinant. Look at the class determinant here. That's what you use to determine the class. So to know our D3 class, we'll get to use 3 summation F all over 10. That is 3 times 30 all over 10 is equal to 90 over 10. If it is 90 over 10, that will be 10. And that will be 9, sorry. 90 over 10 will be equal to 9. Again, we come to the cumulative. We always trace the class using the cumulative frequency column. Now, where does 9 fall? 9 is above 8. So it falls in this class, this 17 here. So our D3 class is this class. So I'll write it out. D3 class is equal to, where 74, it will be 15.5 to 20.5. Here our L is equal to 15.5. Our cumulative frequency before that class is 8. Above 17, that is 8. And our frequency of the D3 class, the frequency of that class is 9. So we have all the things that we need to calculate our D3. So our D3 by calculation will now be equal to L. L is the lower class, that is 15.5 plus 3 summation F over 10 is 9. So this will be 9 minus the cumulative frequency before that class is 8 all over the frequency of that is 9, then times 5. So this will be equal to 15.5 plus 9 minus 8 is 1 all over 9 into times 5. This will be equal to 15.5 plus 5 all over 9. 5 times 1 is 5, so 5 all over 9. So our D3 will be equal to 15.5 plus 5 divided by 9. 5 divided by 9 is 0.56. 0.56. So this implies that our D3, when you add 0.56 to 15.5, you are going to have 16.06. 16.06. So our third decile is 16.06. Again, let us check where it falls, whether it is in line with the D3 class. The D3 class is 15.5 to 20.5. 16.06 falls in this class. So we are good to go. So our D3, take note of it. Our D3 is 16.06. Now, let us go ahead and calculate our D5. Our D5. Our D5 is the 5th decile. And it will also interest you to know that our D5 is the same thing as the median. It's equal as the median. We prove this using the set of ungrouped data. And if you want to prove this using this data set, why not? It's possible. So now we want to calculate our D5. So our D5 will be, that means our I here is 5, will be L plus 5 summation F all over 10 minus the cumulative frequency before that class all over the frequency of the D5 class times, of course, our class weight. Now again, the determinant is this. So you have to determine the class before you calculate the D5 value or the value for the D5. So our D5, the determinant is 5 summation F all over 10 is equal to 5 times 30. Remember, our summation F is 30, the sum of the frequencies, and that is all over 10. 3 times 550, so this will be 150 all over 10. So this will be equal to 15. Now, the D5 class, where does 15 fall? It falls here between 8 and 70. So this our D5 class will be equal to 15.5. 15 falls here under 17. 15.5 to 20.5. Here our L will be equal to 15.5. Then our cumulative frequency before that class above that is 8, is equal to 8. And our frequency of the D5 class, the frequency of that class is again 9. So we can come ahead now, or we can go ahead and calculate our D5. And again, our D5 is also equal to the Q2, the second quartile, and it's also equal to the median, and it's also equal to the 50th percentile. We proved this using our ungrouped data. You can also go ahead and prove that using this. So now let's calculate. Our D5 is equal to our L is 15.5 plus 5 summation F over 10. We calculated that is 15 minus the cumulative frequency before that is 8 all over the frequency of the D5 class is 9 times our class weight, which is 5. So this will now be equal to 15.5 plus 15 minus 8 is 7. 7 over 9 times 5. This will be equal to 15.5 plus 7 times 5, 35 all over 9. So our D5 will be equal to 15.5 plus 35 divided by 9, again is 3.89 plus 3.89. So by implication, our D5 is equal to 19.39. 19.39. And this is equivalent to the D2 we calculated. I hope you are taking your notes. Please be patient and watch this video to the end. You have a lot to learn. You can see me breaking it down so that you can have an easier and a better understanding. So you can see this is the value. If you have been taking your notes, this D5 is the same value we got for the Q2, the second quartile. The second quartile is the middle of the quartiles. The D5 is the middle of the deciles, because deciles you are sharing total equal parts. Then the P50 is the middle of the percentiles. So that is what we have for the D5. Now I want to quickly go ahead and calculate D8. Let's calculate one more so that we can get some interdecile range. So I want to calculate the D8. I want to calculate the D8. I want to calculate the D8. So calculating the D8, D8 is equal to L plus 8 summation F over 10 minus cumulative frequency before the D8 class all over F frequency of the D8 times C. So now let us determine the D8 class. D8, it will be 8 summation F over 10 is equals to 8 times 30 over 10 is equal to 240 over 10 is equal to 24. Is equal to 24. So that it falls, where does 24 falls? Under this 26. So our D8 class is equal to 25.5 to 30.5. 25.5 to 30.5. Here our L will be equal to 25.5. Then the frequency above that, the cumulative frequency before above that one, before that one, the cumulative frequency before that one is 22. And our frequency of the D8 class, the frequency of that D8 class is again 4. Now let us go ahead and calculate our D8. Our D8 will now be equal to 25.5 plus, of course, 8 summation F over 10 is 24 minus the cumulative frequency before that is 22 all over 4, which is the frequency of the D8 class, of course, times 5. So this will be 25.5 plus 24 minus 22 is 2 over 4 into times 5. So this will be equal to 25.5 plus 10 over 4. 2 times 5 is 10. So our D8 will be equal to 25.5 plus 10 divided by 4 is 2.5 plus 2.5. So this implies that our D8 is equal to 25.5 plus 2.5 is equal to 28. So our D8 is 28, the 8th decile. And where does it fall? It falls between 25.5 and 30.5. So it means that we are on track. What we have calculated is on track. Now let us see, please take note of this value. Let us see how we can calculate the interdecile range and semi-interdecile range. We'll just pick two deciles. We'll calculate the interdecile range and semi-interdecile range. Now let us look at the we must pick two deciles. Let's look at it between D8 and D3. D8 and D3. So our interdecile range is equal to D8 minus D3. So our D8 is 28 minus our D3 is 16.06. So our interdecile range between D8 and D3 will now be equal to 11.94. Then now the semi-interdecile range between D8 and D3 will be equal to semi-interdecile range will now be equal to D8 minus D3 all over 2, and that is equal to 11.94 all over 2. So our semi-interdecile range between D8, that is the 8th decile, and the 3rd decile is 5.97. 5.97. That's how we calculate the interdecile range. Now quickly let us look at percentiles. let us quickly look at percentiles before we call it a day. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. I teach mathematics and statistics topics that are beneficial to undergraduate, postgraduate students, even students of mathematics at all levels. Various topics will be coming up. So please subscribe to my channel and click on the bell button so that anytime I upload a video, you will have a notification. Then now we are looking at percentiles. Pi is equal to L plus I summation F all over 100 minus cumulative frequency before the class all over frequency of the Pi percentile times our class size. You can see percentile is sharing the data set into 100 equal parts. Now quickly, I want to start with the 25th percentile. So I here is 25. This will be equal to L plus 25 summation F all over 100 minus the cumulative frequency before that class all over the frequency of the 25th percentile times our class width C. Now the first thing we need to do is to get the 25th percentile class. So P25 is equal to 25 summation F all over 100. So it's equal to 25 times 30. Our summation F here is 30. Then all over 100. 25 times 30 is 750. Is equal to 750 all over 100, and that is equal to 7.5. 7.5. So now, where does 7.5 falls? It falls here. It falls there. So our P25 class, it falls, it's not below 8, 7.5 is not below, but it's greater than 3, so it falls here. So it will be 10.5. Remember, you are taking it from the class boundaries, 10.5 to 15.5. So here our L is equal to 10.5. Our cumulative frequency before that class, before it is 3, the cumulative frequency before it is 3, and the frequency of the 25th percentile, the frequency is 5. You can see we have brought out all the things that we need to calculate that. Now we can go ahead to calculate our P25. It's now equal to L is 10.5 plus 25 summation F over 100 is 7.5. 7.5 minus the one above it, the cumulative frequency above that class is 30 all over the frequency of that particular class is 5. Then times 5. So this will be 10.5 plus 7.5 minus 3 is 4.5 all over 5 times 5. You can see this 5 will cancel this 5. So our P25 is equal to 10.5 plus 4.5, and that is equal to 15. And you can see this is also equal to our Q1. Our Q1 is 1/4 of 100. That's the first quartile. So 1 over 4 times 100 is 25. And the P25 is 15. Our Q1 is 15. You can see that that has also been established. Now, this value 15, it falls within this class between 10.5 and 15.5. That is where it falls. It's not above 15.5 and it's not below 10.5. So it falls within the class. So the answer is correct. That is how you check. When you write out the class, under examination condition, they can tell you to find the P25 class. The P25 class is different from the P25 value. The P25 class is 10.5 to 15.5. While the P25 value itself is a single value, is unique, is 15. So you need to know that. Now let us see how we can also calculate the P50, which is the median, which is the 50th percentile, and it's also equal to the second quartile, and it's also equal to the 5th decile. So our P50 is equal to L plus 50 summation f all over 100 minus the cumulative frequency before that class all over frequency of the P50th class times our class size or class weight. Then now P50, let us determine the class using this determinant. So we are using 50. I told you this, I call this the class determinant. You first of all determine the class before you calculate the value. So this will be 50 summation f over 100 is equal to 50 times 30 over 100. Our summation f is 30. So this will be equal to 5 times 3, 15, 1500 all over 100, and that is equal to 15. Then you come here again, where does 15 fall? Of course, it's not this 8, it has left this, it is now here, so it falls here. So our P50 class is equal to 15.5 to 20.5. Here our L is equal to 15.5. Our cumulative frequency before that class is 8, and our frequency of the P50th class, the frequency of that class again is 9. Now we can go ahead and calculate our P50. Our P50 is equal to L is 15.5 plus 50 summation f over 100 is 15 minus the cumulative frequency before that class is 8 all over the frequency of that class is 9, then times 5. This is now equal to 15.5 plus 15 minus 8 is 7 all over 9 times 5, and this is equal to 15.5 plus 7 times 5, 35 all over 9. So our P50 is equal to 15.5 plus 35 divided by 9 is 3.89. 3.89. So this implies that our P50, our 50th percentile, is now equal to 19.39. 19.39. Look at the answer. Can you see it? So now again, let us check. The P50 class is 15.5 to 20.5, and 19.39 falls within this class. It is not above 20.5 and it's not below 15.5. So we are on track. This is how we calculate the P50, and you can see this value is also equal to the Q2, is also equal to the D5, and this is the half of 100. So this value, if you look at the Q2, the second quarter we calculated, it was this value we got. If you look at the D5 we calculated, is the same value we got. So these things are very easy to calculate. Now let us calculate one more percentile, which is the 75th percentile. The 75th percentile is also equal to the Q3, because 3/4 of 100 is 75. 3/4 of 100 is 75. So now let us calculate that. Then after that, we go ahead to calculate our interpercentile range. Now our P75 is equal to L plus I now is 75. 75 summation f all over 100 minus cumulative frequency before that class all over frequency of the P75th class, 75th class, times our class size C. Now let us get the class where it falls. P75 will now be 75 summation f all over 100. I told you this is our determinants. So this will be 75 times 30 all over 100, and that is equal to what? 75 multiplied by 30 is 2250. Is 2250 all over 100. That is equal to 22.5. Now, where does 22.5 falls? It is above this 22 here. You check it from the cumulative frequency column. 22.5 has left this particular class. It has come here because by 0.5 it has left this class. So now our P75 class will be equal to 25.5 25.5 to 30.5. Then our L is equal to 25.5. Our cumulative frequency before it, CFB, is equal to 22. Then our frequency of that class, our frequency of the P75 class is equal to 4. The frequency here is 4. So we can now come ahead and calculate our P75. So P75 is equal to L. L is 25.5 plus 75 summation F over 100 is 22.5 minus the cumulative frequency before that is 22 all over the frequency of that is 4. Then you see times 5. So this is equal to 25.5 plus 0.5 over 4 times 5. So it's equal to 25.5 plus 2.5 over 4. So our P75 will now be equal to 25.5 plus 2.5 over 4 is 0.63 plus 0.63. This implies that our P75 is equal to 25.5 plus 0.63 is 26.13. 26.13. So our Q3, if you look at it, is 26.13. Our P75 is also 26.13. Now again, you check the class. The P75 class is 25.5 to 30.5, and this value 26.13 falls within that class. It's not above 30.5 and it's not below 25.5. If it's above it or below this, then something is wrong somewhere. You have to trace and check where the problem is coming from. So you can see that we have gotten that clearly. Now let us look at what we call the interpercentile range. We will look at the interpercentile range, and we'll also look at the semi-interpercentile range. The interpercentile range and the semi-interpercentile range. So interpercentile range between, let us look at it between P75 and P50 is possible. P75 and P50. So our interpercentile range is equal to P75 minus P50, and that is equal to our P75 is 26.13 minus our P50. Our P50 is 19.39. So our interpercentile range is equal to, for these two, is 6.74. So our semi-interpercentile range for between P75 and P50 will be equal to semi-interpercentile range is equal to P75 minus P50 all over 2, and is equal to 6.74 over 2, and that is equal to 3.37. So beloved, you can see that this topic is as cheap as anything, because everything has been easily explained. So we have looked at the quartiles, the deciles, and the percentiles for grouped data. We looked at the interquartile range, semi-interquartile range, interdecile range between two values, and semi-interdecile range, and interpercentile range and semi-interpercentile range between two values. So we have done this, and I believe you have gotten a wider knowledge on quartiles, deciles, and percentiles for grouped and ungrouped data. This is for group data. So please subscribe to my YouTube channel, Dr. Chris Esekaibe, subscribe to my channel. Click on the bell button so that anytime I upload a video, you will have a notification. Like my videos, click on the like button also. Share my videos on all social media platforms, your Facebook, your WhatsApp, status, and the rest of them. And as you do, God will bless you. So please look out for my next video. My next video, I will be looking at measures of dispersion or measures of variability. Measures of dispersion or measures of variability. We shall be looking at the range, the mean deviation, the standard deviation, the variance, and of course, you know, the quartile deviation is also part of it. So please watch out for my next video, and as you do, you will enjoy it. So I am taking you through a series in statistics and in mathematics. Very shortly, I will also be bringing us topics in mathematics like calculus and the rest of them. So we'll be looking at them step by step. I hope you enjoyed this video. Share it with your friends, share it in your WhatsApp platforms, share it in your social media platforms, share it everywhere, share the link. Let the knowledge be part of those that are sharing knowledge. And as you do, God will bless you. Subscribe again to the channel, Dr. Chris Esekaibe. Click on the bell button so that anytime I upload a video, you get a notification. And as you do that, God will bless you. Enjoy the rest of the day. See you in my next video. Measures of dispersion or measures of variability, where we shall be looking at the various measures that help us to study dispersion and variability in any data set. God bless you. Bye. Enjoy the rest of the day.